So I'm working here as a senior lecturer for ICT. I teach software development and AI, and I'm involved in the research development and innovation projects related to those topics here at Haaga-Helia. Up till recently, I worked, or like 1 year ago, still at Silo AI, which is one of the bigger AI consultancies in Europe, quite a bit in headlines. Was acquired by Advanced Micro Devices (AMD) last summer amidst this AI hype and investment scene. And while working there a couple of years back, I was also leading this cloud AI and MLOps technology area. So I was building kind of the capability of doing what is called like MLOps or machine learning operations, understanding and set up for Silo AI as well. I have been working with software and machine learning and infrastructure and platforms for a long time at my career, but here we then, while working at Silo with my team, we also did a bit of like research and kind of product development activities to come up with the sort of like more productized setup that could be used to benefit the machine learning R&D, especially regarding the kind of the needs of like those big organizations that really utilize AI and also develop that. So with the largely with the kind of example of this platform, I'm going to talk about the streamlining this AI and machine learning related R&D. It contains many kind of phases when you do such a research and development, from what is called like experimentation phase and running machine learning experiments to then actually taking those models into use. And this, of course, like this experimentation is very close to the kind of research that we do in the academic world, and then in the actual work when we are trying to derive the value of the machine learning and AI, then we need to also deploy those models and integrate those to actual systems used by different organizations or the products that they offer. And these MLOps setups and platforms can really help in all that workflow and that process. And we did this work, like briefly mentioning, in this ITF-funded IML4E project, that from Finland also like included University of Helsinki, with whom I'm still like continuing to collaborate over these matters, as you will see shortly. And then we had a like bigger consortium there with, for example, Fraunhofer Institute from Germany. And the link that you can see there, you can have a look at the when you wish at the platform that we developed. So basically, what we came up at Silo was this machine learning operations platform that was based on the open source technology. And then around like 1 year ago, around the time I was leaving, we also decided to open source that for the general public, so to benefit like everybody who could use such a or want to use such a platform to improve the machine learning R&D and work. No worries, I used the yeah. So perhaps it's good to recap, like with the machine learning. Basically, these are like terms used kind of like in the mixed way that we are sometimes talking about AI, nowadays more and more about AI but less often about machine learning, which was still like the term used for some years ago. But basically, if we really recall, then the machine learning is about creating the AI components from some data. So that is the scope of the machine learning, and with the machine learning, we produce some sort of like AI component and use that AI component for a certain purpose. And basically, like what happens in the machine learning is that we put the data together with some machine learning training algorithms that are implemented as some sort of like software code, usually in Python, because the Python is the programming language and provides many frameworks used in the machine learning work. It has like the biggest ecosystem globally. And then this kind of constitutes kind of like a machine learning job in the sense that is run on some compute. And often when we are using modern so-called deep learning based machine learning with the neural networks, deep learning neural networks, then we require quite a bit of like compute power, and we need the specialized hardware like graphical processing units or GPUs for that. And now, of course, like with the recent news of DeepSeek from the Chinese provider, we have seen that can be done with modern GPUs, but recently the discussion has been around like building a lot of like data center capacity and a lot of like compute capacity for running the trainings, especially regarding the big models like the large language models and such that are powering the GPTs and ChatGPTs and so forth. And with these jobs, we basically create machine learning or AI model. And in order to take that into action, like into use and put it to the kind of like production setting, we have to deploy them somehow. And often they are deployed as behind some web APIs, behind some like so-called REST APIs, often online someplace, and then used for certain purpose. So in quite like some system or person is making like giving that new data, that model, and then it produces some inference on that model, whether it's classification or estimation of some numbers or producing new text from another text or body of text or something like this. And very often now this use happens as part of like web applications. So we can build like regular web applications that have like front ends and back-end systems and databases, and we are using perhaps like some services from the internet with the other APIs, but they also then integrate now more and more to these machine learning models and use them as a part of the software system. One important thing to note about the machine learning is that it's very different from like a regular traditional software development. It's kind of adding on top of that something that is completely new. So it's non-deterministic in that sense, because these training algorithms are stochastic, that you don't just implement a training job and then get something, some validly working, properly working machine learning model out of that all the time. But that's why we are talking about experimentation in the machine learning, and we have like these jobs that I described are actually named experiments in the field, and you might need like multiple ones to actually achieve any working model. And there are several elements to like this whole setup. So everything from running these experiments to organizing or being able to use the compute needed for those training jobs and experiments, to managing the very many kind of work products that we produce when we need to perhaps run 10 or 100 or even 1,000 experiments or whatnot. And then we need to also take those models like easily to practice to integrate to that software. And this brings about the kind of like this consideration for what can be called like AI model life cycles. So we have the training parts, then we need to manage the work products that come from those training or development parts, and then we need to somehow manage the model deployment. And this needs operational support, and this is where the machine learning operations or MLOps comes in. So we benefit from the MLOps in the ML R&D work in the same way as software development benefit from what is called developer operations or DevOps. We can more easily manage the process, and we can more easily do all the trainings and roll out all the good models into use. So, but quality and productivity in some sense. If we are not going to go into detail this, but this is exactly what happens in these very like big organizations that do machine learning as part of their business also, or as part of, like, for example, in the case of Google, their enterprise research also. This is like architecture from Google. So there's a lot of like engineering like related to the training and then deploying and continuously improving the models. So it's very far from perhaps this kind of like setting where individual researcher or company data scientist might be doing the machine learning with the Jupyter notebooks and running the individual solo development effort. And basically in that silo AI R&D work with MLOps, we developed this that platform that I was talking about, and you can run that platform in various different like environments from like any basically commercial cloud or even in the private data centers of organizations, and even supercomputing environments like the CSC, the IT Center of Finland. Yeah. But then what we had at Silo and what was not open source, but what was like I got redeveloped here at Haakahelia was also this like combining these more like model related things with the software kind of like DevOps. So like having a fuller end-to-end MLOps in that sense. And basically what we have through this kind of like MLOps setup, which is actually pretty close to the like the basic like services that you get from AWS SageMaker or from Azure ML or Google Vertex and that kind of like commercial MLOps platform, is that you can share this environment with others, and the environment takes or the platform takes care of like orchestrating those ML training jobs for you. So you can, for example, if you need to buy that GPU compute, you can put that to the single cluster and then have the platform on top of such cluster, and it can share that expensive compute between the different developers like smoothly. And it also like has services to keep record of all these training jobs or experiments that you need to have. And since they produce all the models, and those models are somehow related to like code that was used for the training and the data that was used, a particular subset of data that was used for training, and then you have some sort of like validation metrics for the machine learning model. So you can manage all that information, so the models, but also all this metadata regarding the models on this platform easily. And then it provides also services that you can deploy the models easily as web APIs. And this software developer or software development kind of like addition on top of the platform then makes it possible that the machine learning developers, whether they are researchers, data scientists, or whomever, they can work with usual code versioning practices and basically with Git systems, and then can focus on writing what they can best. So what the Python code for the ML experiments and that kind of things, and for the data processing, and then you can basically automate even largely the use of this kind of like platform. So it can be like this kind of setup can productize this pretty complex way of like using technologies as part of your machine learning R&D. So this platform, it consists in itself from various web services, and those web services, they are themselves like these open source technologies, and they provide also like nice interfaces. So you can use the platform programmatically through different interfaces, but then you have the possibility also to inspect different kind of like phases of your work, as well as then the products of your work products from your machine learning development on that very same platform using the services available there. So for example, here, this graph here is a pipeline that has been constructed to be run on the platform. So you have training, some validation, deployment, and finally inference steps in that graph. And then you can, when you submit such a like pipeline for the execution, you can inspect like its progress in the system through the web UIs. And similarly, you can view also those products like those models and the metadata associated there, and make even the decisions like, okay, now my experiments produced like 20 model candidates, and this one seems to be the best working one, so I'll select that for the deployment, and you can make a setup where that deployment happens when you select that. So these, like we selected when we started this job, these are kind of like initial technologies actually. What we selected there. There's a Kubeflow open source technology. Then there's MLflow and Kserve, which is part of the Kubeflow ecosystem, as well as then the some more like common technical ones like Prometheus for logging and Grafana for visualizing different kind of like metrics. And all of these, they are like they are not constraining the platform. So the platform in itself is customizable and can be extended with extra ones. So the integration is quite loose here, but they are provided as a kind of like a package that you can easily take into use, which is a kind of a difference when you to the scenario where you start using these technologies yourself in some whatever manner that you come up with. And we selected these particular initial technologies for the platform because we saw them at Silo AI when doing client projects regarding machine learning operations and regarding AI solutions, and we had like sales discussions and all. So these are kind of at the cross section, these technologies of like what was and is relevant in the field, and for many big organizations that are doing a lot of like ML activities, but they are also like very well backed by the open source communities, their respective open source communities. For example, Kubeflow is backed by Google. And even though it's not said anywhere, it's very probable that Google is using Kubeflow as a backend of their Vertex AI, their commercial like cloud MLOps offering. So there's a good guarantees and continuity with this going with these technologies. And the thing is that we package this also so that you can run this like in various different environments. So you can, like I said, you can run this in the different kind of like clouds and data center server environments, but you can also run it in the regular standard issue laptop if you want. So the minimum requirements are like relatively low, and this means that you can have like the same kind of like MLOps or ML development setup for yourself in your working computer, like I have it in this standard issue Haaga-Helia laptop, but you can also have that with your team, with whatever team you are working. You could have that same with your collaborators from another organization, and you can have that, for example, in the common space in cloud or in the supercomputing or high-performance computing like centers. And this is kind of the beef partially here also, because this makes it easier to collaborate with others. So it makes it easier for you to like share and disseminate your, whether it's like research results with the machine learning that you have been using, or whether it's some machine learning development that you are putting to commercial use. And you can more easily collaborate with everybody in that regard. So we have a couple of like projects here. So I have continued working with, like I said, with University of Helsinki. So from computer science department from there, they have set up this for at the CSC, the IT Center of Science at Finland, which also hosts our Euro HPC supercomputers funded by Commission. And this kind of like, we are developing that further there. So they developed at University of Helsinki this initial setup where you can use all these different services that that environment has to offer in addition to this platform. And kind of like the mission here, in a sense, is that we can make the supercomputing capacity more easily available and accessible for everybody. Because when you start using this sort of platform, then you can use the same platform for running your machine learning jobs at scale in this kind of environments when you have a version of that available there. And this is actually also, as far as I know, what the Commission wants. So when the Commission has been now granting the funding from the next phase of Euro HPC supercomputers, then this question of like how to make the supercomputing like available for everybody, the academical institutions, but also like companies, it's a kind of like competitiveness related like consideration across Europe, that it just doesn't suffice that you put this in place. People need to be able to use that capacity. And then we are collaborating also with them in extending the use of this platform to large models and the engineering around those large models. Another thing, so we have these different kind of like R&D projects here at Haaga-Helia around using of generative AI for different purposes, and now I'm involved in this one where we combine generative AI with knowledge management, and there can be also these needs, remains to be seen how much, but somewhat for fine-tuning the large models for certain domains. And of course, like with that, we are collaborating here with multiple partners, but here also University of Helsinki is involved, another group from there, and then we can use the platform also in this setup to set the training workflows developed at one organization and by one team, and use the shared environment when needed. Then finally, I'm also like, we are here at Haaga-Helia, we are connecting the research and development and innovation projects to increasingly to student activities in teaching. So we have these advanced courses for nearly graduating students, for example, in software development and infrastructure. So in that context, my software engineering students or software development students are like developing this software DevOps related tooling further for this open source project, and then we have also one on the side of infrastructure for the students who are studying infrastructure setups and maintenance. That's more on the side of the original platform and updating that. But with that, I will conclude. So basically, you can, like I said, you can have a lot of like benefits from like making your machine learning work systematic with this kind of like setups, and also like you can more easily share the resources, both like the infrastructure as well as the work products that you produce in your machine learning work when you are using something like this. And this is like if you are interested, so please join the users and or developers of the open source project. It's licensed under MIT license, so you can use that freely without any fees, and even for commercial users if somebody would have such in mind. And there you can have all the find all the information for getting involved with this. Okay.
Any questions or comments online, or?
I have one question.
Maybe come a little bit closer to the microphones if you have a question. Questions are more than welcome, but.
Yes, okay. So thank you for the talk. It's very interesting. I have at least one question. You said that you were using this in a project at Haaga-Helia, in an R&D project. So I was wondering, which deployment are you using? Do you have it at the CSC?
Yeah, actually, we haven't yet set up that for that project.
Okay.
I have for the student development of the platform itself. I have a setup at CSC, at the IT Center of Science, and that is exactly what is on my mind for this other R&D project as well. So,
Okay.
because the situation in Finland is such that we can, of course, like when we have like academic R&D projects, then it's very affordable for us to use the supercomputing capacity, also the GPUs from CSC. So.
And now, if we had in our project the need or the interest also to use this platform, what would you think would be the effort needed to take this into use?
The kind of the installer for if you want to run it in well, basically in any machine, it's pretty productized. I think the installation in itself is not the big effort. Perhaps there's some effort still involved in like starting to use that. So that's more of the kind of the effort needed in terms of starting to use. So we are trying with the students and with the collaboration with the University of Helsinki is to make it more and more productized in that sense that it would become more and more user friendly, even for people that are like just taking it into use by just few clicks of a button and or like commands and few configurations. So. Yeah, but we can provide we can help with that, of course. Like I can help with that. We have the students now also working that can help with that. So that's part of the info project here at Haaga-Helia. And I'm also like very interested on myself and on behalf of the open source project in any collaboration if in yourselves there would be any interested parties on trying this out. So. Yeah.
Yeah, if you just come up here because the microphone system.
Okay, thank you. Very nice presentation, thank you. It is possible to collect the data from the process of workflow creation execution, for example, to analyze these processes, to identify something like the best or worst practices. For example, not directly the workflow, but the process of the workflow creation. So, for example, you can after that you can say the hospital, yes, this is typical workflow for your case. This is typical workflow for your case, for example, for any other industries.
Yeah, that would be like something on top of this. Like, and yes. Of course, like you are correct and like pointing to the right direction that the any of these like operations, or like DevOps or MLOps or DataOps or whatever, they are not just about the technology and this sort of like platform enablement through a use of like platform and technologies, but they are also about like coming up with the processes and the workflows. But designing those processes and workflows, those are kind of like their own problems and like you said, it can be like a bit domain specific also, like certain like perhaps similar patterns when you set up the machine learning and AI deployment kind of things in a certain organization, but the details might vary, and then you might need to look into that. So I think it's a good research topic also, like and there can be like this sort of like domain or sector specific elements to that also.
Okay, thank you. And one more question. If I have a team, AI or machine learning, do we need people specifically from software engineering to use the MLOps, or for example, we can teach our AI designer to have this experience, this knowledge?
That is the intent, yeah. So it, of course, like with any infra and any environment, it helps if you have like some like more like
maybe
computer technology and the server and infra and platform related like knowledge. So some laboratory engineers or whom not, and perhaps like that is a bit of the kind of a design thinking here, that there would be someone in the team or in the organization that could set up the things if the others run out of like understanding at that. But then with this, especially with this software engineering tooling, the idea is to hide the platform. So somebody can set up the platform, for example, at the here in the IT Center of Science in Finland, and then you can use the tooling to create like such a setup where basically the developer only needs to know about the Python code, and they can just commit that with they need to know a bit like, of course, like then version control related things, but I guess that's not uncommon. So
okay, but can you imagine that you will have a AI researcher in combination with DevOps engineering? It's not typically.
Yeah. It's in work life, it's actually very useful because I was in a consultancy, and the more you have that sort of like skills, it helps. But I don't think, especially in the research, it's very like to be expected or even like required, and that's why we're trying to make more product that make it user friendly, this sort of setup. So.
Okay, thank you.
Yeah.
Thanks, Jukka.
Yeah, thanks.
Leave it open. Okay, so that was our first presenter for today. And let me just get the next one ready. So I'd like to invite Dr. Frantisek Babik from our Ulysses partner, the Technological University of Košice, here to give us a talk on decision support in medical diagnostic path. So looking forward to this one. So thanks very much. That's a glass of water for you. So yeah, hopefully it works okay now.
Okay, thank you. Thank you for the opportunity to be here, and also thank you, Luca, for your presentation, because it created a very good starting point for my presentation. So I believe that this presentation will be interesting for you. It is very short overview how we manage our last initiative in the domain of how we can support the medical diagnostic paths through data analytic methods. So I will present shortly one of our projects, and we believe that we will follow this or the successful result of this project with any other projects maybe in Slovak local condition, but also maybe in European level. No, probably I can use this one. No.
Yeah, sure.
Okay, thank you.
Now that, but you need to stand with the camera. You need to stand here, and then you can read it from there.
Okay. I'm fine. Okay, thank you. Okay, so I will start I'm from Technical University of Košice, Faculty of Electrical Engineering and Informatics, Department of Cybernetic and Artificial Intelligence. And this is very short time overview of our development. So we start in 2020 with our first proposal that we want to obtain funding from one of Slovak research agency. This proposal was successful. We approved new funding. Our project was called Processing Analysis of Ultrasonographic Video Recordings using Artificial Intelligence. Last year, we successfully finished the implementation of this project. I will present the results, but we see that after this project, we were something like on the half of the whole road. So we will continue with other projects because now we are in the at this point that we have some artificial intelligence models or machine learning models, but our end user cannot use these models in his practice. So now we want to find a way how we can deploy these models to his practice and to deliver the benefits, the expected benefits. So our development in this case started that we have our research group has many experience in the field of data analytics. Maybe you know some name of our group that Jan Paralic, Martin Sarnowski, Marek Bundel from maybe any other projects. The last few years we focus on medical data and decision support in this domain, but especially in the case of research. So we have different collaboration, we have different possibility to analyze the data from various health companies or systems, but we still are in the research phase, and we discussed that yes, this is possibility to typically create some research experiment, but the question is how we can deliver this value to the users. Also, we have some experience from European and national projects, and we want to use this experience for this topic. And very good starting point is that our research team consists of a good combination of senior researcher, young researcher, and PhD students. So if you have a good team, you can create a good project and deliver the value. And the whole I can say the whole journey start with one first joint publication that was a result of doctoral thesis, and based on this publication, we found one end user, one hospital facility in Slovakia that want to create or start the journey with us to create some project proposal and working with together. So our target group is represented by thoracic surgery clinic and radiology clinic. They use the standard imaging methods for monitoring post-surgery complication, and in this case they use the chest X-ray. But as you know, using X-ray has some advantages and also some disadvantages. And their motivation was mainly to minimize the radiation exposure, complicated transport of the patient with the chest tube, and also the economic cost reduction. So the main aim was to replace the X-ray with the USG. Now, after the pandemic, it is a very typically used approach, but when we start this project before the pandemic, this was not very standard operation approach. Typically, radiology clinics use X-rays for these topics. But as you know, if you decide to change the diagnostic procedure on the side of the domain expert, you need to reteach these experts. You need to educate them, and it is important to help them, for example, with some AI or machine learning models. At the beginning, we identify some expectation of the both sides, and as you know, because you are expert in this domain, the expectation on the both sides can be quite different. Because, for example, our end user typically expect that easy to understand results. They want to know how the model solved the situation, what are the reasons why the model decided this will be the disease or not. And also they want to have something like retrospective, so they want to know how this model was created. And also this is now some of the main requirements of European AI Act. And these are the expectations from the side of end users. On our side, as a data analyst, we expect that we will have the data set of sufficient quality and volume. We expect that our domain expert will collaborate with us in an intensive way. They will provide to us some know-how. They will evaluate our models, and also they will help us to provide the transfer of the knowledge. And sometimes it's difficult to meet all these expectations, and it is the first starting point is to create some common vocabulary to improve the communication between I can say the two of these worlds. So our knowledge transfer, okay, yes, okay. So our knowledge transfer was based on the direction between our two locations, because our team is located in Košice and the medical facility is located in one small city called Martin in Slovakia. And you see that if we want to go to Martin by foot, it is more than 2 days. So our knowledge transfer was very important. We have different meetings online or personally. And based on these meetings, we collect all information, all knowledge that we need for the effective creation of AI or machine learning methods. And typically in our machine learning or data analytics project, we use this methodology called CRISP-DM methodology. And this methodology is typically used for this topic. Now you can find some new version of this methodology customized for new conditions, for example, in industry or AI projects. And this methodology consists of 6 main phases. And typically in the research, we deal with first 5 phases. So we finish in evaluation, and the deployment is not typically for us. And now we want to deal also with this phase to collect the new experience and use for new project, for a new collaboration with industry and any others. So typically situation on the side of our end user, they use this approach called Blue Protocol to diagnose the patients. So it is something like decision tree, and if they took the data from the USG as this image, they go through this decision tree, through this Blue Protocol, and find the right diagnosis. And their motivation was that if we can help them with some part of this Blue Protocol, that for example, if you have some new medical doctor or you don't have enough time for this case, some model of AI or machine learning can help you that, for example, they will support you in this part and you can follow the other part of this Blue Protocol. So this was the main motivation for them. So we were working with this type of USG images, and they collect for us more than 1,600 USG video sequences. But the important information is that these images was not labeled. So in this project, at first we have to create the labeling for all of these images. Okay, so the third phase of the CRISP-DM methodology is data processing. So if we have this real data, we need to process it, The first that I mentioned was to annotate or label all this data. This labeling was made by a tool called CVAT. It was provided by domain expert, but as you know, probably the time of the domain expert is typically very expensive. They don't have a lot of time to participate of our task. So it took some time to collect all the annotation, but it was very important for us, and they helped us with it. We are very proud of it. Also, we create or implemented one custom Python library for processing directly exported data to provide some augmentation, because you have some images in one form, but if you apply some method of augmentation, you can slightly modify this data to improve the volume of the input dataset and to provide more possibilities for your machine learning or AI model. Also, we tested and implemented some semantic segmentation and different types of data augmentation. So the main aim of this phase was to prepare as much as possible big data set for following modeling experiments, because the next phase is called modeling. I just take together the modeling evaluation, so you can see some examples of our results. So, for example, one possible result is that you say your end user, yes, that we have AI model that has accuracy about 88%, but this number is for them not very important, because they need to know what does it mean, this accuracy, or what does it mean in the case of their domain. So we try to provide for them some or suitable visualization. So, for example, if they want to find something in the USG records or images, we help them. And this was the first time that we are starting discussion that yes, these are the research experiments, and can we talk about how we can deploy this into practice? Because, for example, we were in the situation that we were able to generate this type of visualization in our conditions, but we cannot deliver them in the condition of our end user. So we are starting with deployment. It is the last phase of CRISDM methodology. So we, in intensive cooperation with end user, we provide or we design some prototypes, and the last prototype available from this project was alpha prototype. You can see two screenshots from this portal, but this portal is now in very simple form, because it offers possibility to upload the USG video, to process this video, and to apply some selected method of AI or machine learning to find A lines or B lines in this video. But now this portal offers only possibility to apply this model, to see, for example, the accuracy, to time what time was necessary to generate this model or apply this model. But we now working on some visualization, because for our end user is not important to have, as I say, number, but they want to see the typically that they see on this only on their USG device. So, for example, our aim now is have something that on the right side you have the USG device to collect the data. On the left side you have something that analyze this USG data and help them for the diagnostical path. And typically, when we are now in the phase of beta prototype creation, we deal with different issue that were also mentioned by Jukka. So, for example, we solve the issue that we will use the technical infrastructure at the university level, or the hospital will use his infrastructure, or we will use some infrastructure of the third party. We discuss the issue about data protection, data access, because Slovakia has a very strong law in the case of health data, and also, for example, how we can manage the maintenance, 24/7 help desk, updates, and something like this. And all these questions we want to address in the new proposal that will be now created, and we want to extend our team, so our team of AI, machine learning, and data scientists, this domain expert from thoracic surgery clinic and radio clinic, with some experts from software company, and we believe that we'll extend our experience from the domains of user experience, DevOps, and software engineering. And in this case, they will help us to deliver the value to the end users. So this is all from my case. Thank you for your attention.
Anybody, any questions? Lily has a question, I guess.
Interesting talks. Thank you for the talk. I actually have two questions. The first one is about the output in the user interface. You were saying that the medical doctors are looking for visualizations as something that they can see on their own, the devices that they are used to using. I was wondering if there is any need for some natural language output also, so that the software could explain some of the results in a natural language that is typical in the medical domain.
This is a very good question, and from my experience, the discussion with different, I can say, health department is typically different. For example, some of them, if they have previous experience with some technology or computer science, they can imagine that, yes, for example, this type of approach will help us. But for example, if you have a limited or you have experience only for your domain, they have very, like, not simple, but very clear experience what they want. So for example, if we propose to them, we can extend our technology support with this case, they cannot imagine now. But for example, if we provide to them the solution that meet their objectives, they will test it and use it. After they can think about more technology, more advanced level.
Okay, interesting. Yes, it's like typical when you have advanced technologies. This is what happens in the end users often. So the other question was actually related to this very interesting and fruitful collaboration. So if I understood correctly, it all started from very small. So you had one PhD student who did his PhD thesis on this, and then you had a contact to this hospital. And it seems that this great work really started from very, very small, and that you didn't necessarily have an education, a formal education in medical domain, or such. You were just computer scientists and software engineers, it seems to me, or was it more? Were there more challenges than what you actually told us?
Yes, you are right. Sometimes it's important to create something like success stories. So, for example, if we show the possible end users that we have capacity or we can deliver them expected value, they will start the cooperation with us. So this first doctoral thesis show them that, for example, if we use some AI models, we can help them with the diagnosis. But it was very early starting point, and from the starting point, now we are 5 years later, and I think that also some years are before us.
Yeah, thank you.
Thank you.
One question, I'm not sure if that's your area, but you might know that, but like regarding the medical background of this case, like, what are all the considerations for moving from the thoracic X-ray images to the ultrasound? I used to work myself when I started machine learning related stuff at the hospital in Finland for quite some time, and I was working with the radiology actually quite a big. And as far as I understand, the kind of the radiation dosages of the thoracic X-rays are optimized quite low. So I was thinking that is there some, like from medical point of view, what is the kind of the driver from you moving to ultrasound beyond just like optimizing that further? Is there some regarding doing the post monitoring, some like medical considerations, like that the thoracic X-rays would be worse than non-ionizing radiation?
Okay, I understand. Yes, of course, this question is primarily for the medical expert. But as I correct understand our expert from this hospital, the main motivation is that if you have the patient from this post surgery, it is complicated to transport them to the X-ray facility because they have some chest tube or something like this. So one possibility is that you have to move this patient from one location in the hospital to another. The second is the radiation exposure, you know. So, and yes, they try some USG devices before, and they see some benefits from them in the diagnostic routine. So this was the main motivation aspect.
Yeah. So they have been routinely like using the ultrasound with the thorax as well. You know, because I was thinking that the thoracic X-rays are so prevalent that there's like a good amount of like data, and I know that I think there have been like also in Baltics, for example, some commercial products made for thoracic X-ray diagnostics, but then of course like here we are moving like more special like imaging, where there's then more emphasis on curating a good training data set and labels with the labels and such. So kind of like adds extra effort and complexity also to the setup.
Yes, I understand.
Yeah.
Yes, the most challenging in this case was to label the data.
Yes,
the radio annotation. Yes.
Often is.
Yes. Yeah. Yes, of course. Yes, you are right. Yes. Yes.
Okay.
Okay. Thank you.
Thank you very much. I think you can continue that conversation as well later on and in the research groups as well. So, so thank you, everybody. Now we are going to have our final presentation for the morning. And for this, we will have Rado. Rado, are you there?
Yeah, hi.
Give me 2 seconds while I... Now, everybody is going to give me 2 seconds while I get you set up. Okay, everybody, there's Rado.
I see no presentation.
Hold on. You will shortly. Earlier on, your presentation was duplicated. Okay.
Previous presentations were shared. There's no problem.
I need to make sure that all of the screens and all of the people can see everything.
Okay.
Now, can you see the slides?
Not yet.
Okay, hold on.
No, perfect.
No, okay, hold on 2 seconds. You don't need to see me here because you're speaking. Let me just try and get it so that I think we will just do it like this.
Slide is up here.
Hold on. Okay. Now,
Okay,
Rado, can
perfect.
you hold on 2 seconds? Can you see now?
Yeah.
And then I gave you control over the thing, but maybe it's not going to work. So I think I'll just change the slides for you. How does that sound?
Oh, it would be better, I guess. I will ask you to move next slide. Okay. Okay, so thank you so much. Hi to everyone who joined this presentation, and thank you for the opportunity to present our research focus and our, for now, informal living lab focused on AI for supply chain and procurement decision making. I'm Radoslav Delina, professor of finance, not from artificial intelligence, but from finance and Technical University of Košice Faculty of Economics. And I'm also Chief Scientific Officer under our Innovation Hub. And generally, my research team is focusing on data science in different socioeconomic areas. Also, the most significant is artificial intelligence and big data potential for decision automation in supply chain management or in this procurement area in commercial and public sector. So regarding this specific research area, the main goal is to develop some AI machine learning service for, let's say, cognitive decision intelligence for all types of procurement strategies, from operational bottleneck leverage or strategic procurement in both sectors, this commercial and private and public. And this decision automation covers all phases of procurement, from sourcing, looking for suitable supplier, to post-contractual management of phases. So this presentation will be, I hope, short, and it will be something like overview of what we are doing, and we'll go not too deeply or in big details, but if someone will be interested, we are able to arrange some more technical meeting, and I will be happy to enhance cooperation. So, William, if you could move on. Perfect. So, when we are talking about decision intelligence in procurement, we are focusing mainly, but not only, to 4 core areas. Yeah, in market and supply chain understanding, we would like to find such AI-driven solution which are based on trusted and big data from the market and different sources, which I will present on the next slide, for different decision problems, like how to find a suitable supplier, how to find a new reliable supplier, how to identify market gaps or market opportunities for procurers to be able to bring some added value to their organization, how to identify and manage or disrupt some unfair practices like collusive behaviors between the suppliers or corruption between supplier and procurer. So it means we are analyzing or we are applying data science from different methodologies or methodology approaches to understand the market situation for sourcing strategy definition. But of course, we are focusing also on predictive analytics and prediction model development. For example, how to predict behavior of suppliers or specific supplier group. How to identify the optimal sourcing or negotiation strategy or auction strategy for negotiation, for example, We are using really complex auction algorithms here in this living lab, and based on real data from real processes. To find or to predict such a strategy, which will provide the best potential tender performance or results. Yeah, so this is classical prediction task, but also how to manage prediction model applied in real-time processes, how to manage deviations from expected results, and so on and so on. So these both areas are necessary also for developing and deploying efficient and trustworthy decision automation service on the final stage. Yeah, where we are building some solution for especially for operational procurement, but providing also some or ensuring some human control over the automated bot. Yeah. So nowadays we are also focusing on innovative value added or innovative added value of procured products and services through some recommendations for tender definitions, which has great potential to be a future best practice to bring highest competitive value to the organization. And this area of procurement of innovation we will present tomorrow as a project proposal for future calls. So if you will be interested, you are welcome. William, next slide, please. So during more than 20 years, I guess, I have been cooperating with industrial organizations, but also with public organizations and their procurers, as well as with software providers or providers of software or procurement softwares. Yes, during these years, I was able to due to trusted communication and cooperation with them, establish quite big data warehouse for transactional data and for supply chain data, formalized in our living lab. It's really still not certified by NL, but I hope in the near future it will be. So we are collecting, aggregating, processing, analyzing huge amount of transactional data from really different sources. As you see, the main source is, of course, some procurement platforms, yeah, like here in Central Europe, Tenderbox or Proebis, which are Proebis is largest provider of complex procurement solution here in Central Europe, with more than 600 large clients from industrial and public sector. So we have access to data from real processes, from real auctions, and we are trying to enhance also this data from other sources to better understand supplier behavior or risk, like sources like business registries, public procurement registries, financial statement registries, invoicing systems, or research and innovation repositories. We have now data mainly from Slovakia and Czech Republic, which are really complex and detailed, but we are trying also to enhance data from other European regions. Now we are working also with not so detailed data as we have from Slovakia and Czech Republic, like TED from public procurement data and so on. But we are working with the data complexity, and we are able to utilize different data quality, right, for different decision tasks. Of course, we are processing and transferring data to our purposes, some transformation I will explain in later slide. So you see, we are calling this data space something like data fusion as a solution which aggregated the data, and it's base for training and developing new AI models and data-driven services for research, but also for commercial purposes. We have one startup from this living lab. We are working also on psycho development. It's something like Copilot for sourcing intelligence. It means our models are integrated in legacy systems, in their internal softwares. So together we are developing something like, we are calling the quantum sorcerer. It's only working title now, but it's aggregating hundreds, thousands of auctions from different auction algorithms, from different transparency settings or different market situations. And we are trying to predict the most efficient strategy, and also to use for decision automation to set up such a negotiation and execute such a negotiation strategy which will lead to best outcomes. And together we are developing procurement of innovation services to recommend tender definitions, integrating latest research and innovation achievements from different sources like scientific publications, project repositories, and so on. And also we are trying to integrate our living lab and all these research and innovation activities into the educational processes here on our faculty and also on Faculty of Informatics, Electrical Engineering. This integration is also part of one of our proposals for Erasmus call. So if you will be interested, we can discuss it more later. So we are talking really about big data, as we are processing millions of tenders. Not all are complex auction, some of sealed classical tenders, but there are millions of tenders and suppliers. And when you are transforming such data, for example, to analyze and identify supply portfolios, different supply portfolios, you are working with billions of records. And more than, and we set up or developed or transformed this data into more than 700 behavioral indicators or predictors, for our AI models. We would like really to bring unique solutions, something like backend service integratable or integrated into different market software solution for procurement. So aggregating a lot of data from different sources, somehow process them and deliver new added value or new knowledge to back to legacy systems. William, if you can move on. So I guess you feel that the procurement is really complex research area where we have plenty of research problems and honestly low research capacity to cover all of them, but we are trying really to do our best. Here are a few. We are focusing strongly on these weeks, especially research around collusive and risk supply chain signals, how to manage, how to disrupt them. Of course, we are also developing something like commercial services within our startup. Some of these problems are still waiting or are in progress or are final or in progress, but some of them are still waiting on some help or cooperation with other researchers because it's too much for us. But we have expressed so big interest from our stakeholders, end users, companies we are working with. So there is this topic is really very, very perspective for us to develop, also in research, but also in this innovation point from this innovation point of view. Very, very perspective is this automation in category management, especially there's a risk categories like based on Kralitsch metrics or based on own methodology. There are really breakthrough models how to help decision makers in procurement processes to increase efficiency of their decision making. And it shows really big multi-dimensional complexity in this area. Some non-standard supply chain problems we will present on the end. But if I can, William, we can move next slide to explain a little bit this complexity. We have really different dimensions, but but one is very interesting, and it lies on very specific situation in which you can make some decisions. For example, product categories where you have to fight with specific biases, imbalance data problems. But we are very interested on time-related aspects, which can be called like non-standard time series contract or transactional data, where multidimensional perspective increases computational or also methodological complexity. For example, you have to analyze behavioral patterns in time across different following tenders where you as a supplier were involved successfully or not. So we are examining this evolutionary aspect or indicators of all contracts which were won by given supplier in some order. Or we can analyze performance or behavioral patterns of procurement managers or his organization solely. But very interesting is to analyze evolution of bilateral contractual or tender relationship and compare and benchmark them between supplier and procurer. Evolution of tenders where specific portfolio of suppliers was involved. And this raises really the complexity, but it's very interesting for AI and big data research problems. So sometimes we really have to find suitable HPC cloud. And now we are really waiting on our own HPC cloud here on TUKE, which will be ready, I guess, on the end of this year. So I hope we will be able to move on. Okay, so William, next slide, please. When we are talking about methodological view, we are combining traditional, predictive, or classification approaches or models with more modern line generative AI for proposition of new services. NLP or causal machine learning, which is very interesting for uncertain environments and models. This we are now applying especially in non-standard unfair behavior signals suspicious by collusive agreements between suppliers. Yeah, so we have already some research results. We are trying now to publish them. So if someone will be interested in, I will be really happy to discuss more about this topic. And if we can move by some, for example, we are also analyzing, or these unfair practices are based also on different ownership interconnections between suppliers in tender or between suppliers and procurers, which can show or signal some corruption incentives. Besides of standard view, we are also examining distance parameters between owners, stakeholders, supplier companies, which show very interesting results. And all these results from research, we are able to put into new data service or recommendation service or AI service as support for decision makers to reduce risks, increase resilience or performance of the tender. Here we see some specific results from one supplier group on the right graph. If you see, you are not, or procurer were not able to negotiate some savings. Although, if this group of two suppliers were disrupted by another supplier, the savings price was improved. Savings were improved. For example, here you see on the left graph these red points. Yeah, so you are able to achieve better prices, better conditions. It's not about prices. It's also about some non-financial criteria when you are negotiating. But you see this difference if they are alone, these two suppliers, and if they are disrupted by some other. supplier. So it's really fascinating to see what is possible not only in public procurement but also in commercial procurement to analyze that and to find some solution how to disrupt such negative behaviors. William, next slide. So as I said, we are working also with these interconnections, these network analysis. And next slide, please, because I see the time is tough. And I said we are working with the most significant software suppliers of complex procurement or reverse auction tools or provider, in Central Europe, together with his client. This provider, his name is Proebis company. It's quite known here in Central Europe and Eastern Europe. We have established together with his clients a procurement platform which we are calling Procurement Board, where around 30 procurement leaders, gurus, something like evangelists from large industrial companies are discussing trends, problems, especially in this digitization transformation and how to use AI and data to improve their processes and decision making, and the value they are contributing to organizational strategy. So together they have very strong professional conference, the biggest or largest here in Central Europe. Yearly, there are more than 600 or 900 companies or organizations there. So it's really very good place to discuss, to start collaborate with potential end users. On this conference, I received also first prize within a fair sourcing award for presenting this potential of data and AI for decision automation. So I built very close and friendly relationship with these industrial leaders or procurement directors, which is very, very beneficial for our research activities within Living Lab, and also for our startup or commercialization potential. Yeah, we have a really nice number of stakeholders from practice, around few hundreds from really different sectors. So we are, I have to say also that this procurement or community of procurers is so strong and so multidisciplinary. They have to procure different technologies, different solutions. For example, they're asking me if I am able to find somebody who is able to deliver some sensor for maintenance predictions and so on and so on. So these procurement processes and also this AI tool could be very useful in different research areas. For example, if we can move on, we are, William, please, next slide. We are also working on not very traditional standard supply chain topics. Yeah, for example, I don't know if you can imagine that procurement or decision making in procurement can use satellite data. For example, when we are working with one brewery, this Asahi, this large multinational company, they, for example, are able to use satellite data for strategic planning of their strategic commodity. Yeah. So they would like to know and to be prepared for the quality of harvest, amount of harvest, to be really prepared if the price will be this and this, and they are able to be prepared, and they are able to provide more efficient strategic plans. Together, we are also working with health insurance companies. For them, for example, evidence-based medicine based on data validated the utility or the impact of, for example, some therapy can be part of supply chain information that, yeah, I will, or this health insurance company will continue with financing such medical activities, or it was special project for disabled children related to some assisting rehabilitation therapy. So it's really interesting also that we are able to influence procurers by different non-financial criteria, not only green criteria, but also social criteria. I am responsible for digital transformation of social economy here in our Ministry of Employment and Social Service. And it's a very wide area of opportunities where we are able to apply our experience from supply chain or digitization of supply chain into different fields. So I hope I'm in time, I guess. Thank you, William. I guess one last slide is there, but really this program of innovation, I would like to lead on next presentation tomorrow, where we will explain this topic as a project proposal, for how to improve knowledge transfer, this translation of research and innovation results into the practice, how to integrate the knowledge directly in decision-making processes, how to map supply and demand for research and innovation concepts. So if someone will be interested, tomorrow we will explain it more in details. Thank you so much.
Lovely. Thank you, Rado. Has anybody any questions or comments? Maybe Lily is, or and Dimitri too. Oh, actually, well then. Oh, everybody. Okay, well, come up here.
So you can go first.
Okay, Rado, we've got some questions for you. Maybe I'll take up, because the microphone's here, so you got to come up. I'll stop the sharing. Hold on. Let's do that. Now, and if you come here, you can see Rado, and then hold on, let's put Rado there, or at least you can, he's there, but he can see you there. So.
Hello.
I see myself, but no problem. I will hear you.
Hello, Radoslav. My name is Dmitry, and I'm senior researcher at Haga and I'm interested in whether you use ontologies or knowledge graphs for understanding data, for integrating data, or some other purposes related to your analysis.
As I said, it's the really wide or various wide research problems applicable in this topic. So we have plenty of methodologies, knowledge graphs, decision trees, causal trees we are applying. But after these 20 years, I can say that the most important is to preprocess the data and suitable transformation. Because, for example, we have experienced that if we were able to transform data, for example, from this time aspect, we were able to reduce computational time and also increase the precision of AI. Also, this term precision of AI is not so simply to explain, because it's a really multidimensional problem. But after these 20 years, I see that sometimes we are able to apply more simple models with better results when we will preprocess the data in really correct ways. And I guess this is new. It should be new field of study, or how to say, because this is such a complex problem, how to prepare data for models, that sometimes it's really bigger problem that train some AI models. I don't know if I answered your question, but really, if you are interested in these problems, we established a research group under Ulysses, where we would like to enhance this living lab internationally, enhance data warehouse by national data and so on and so on. So we are able to cooperate more intensively in this field.
Lovely, great, thank you. I think we had one more question. Frantisek, did you have a question for Rado?
Yes, of course.
You can go here so you can see you.
Yes, of course, but we can discuss them
when you go home, yeah.
Frantisek.
Yeah, I would like to ask.
We have to discuss in Finland, not here in Košice, you know. Thank you, Hagahelia, for that.
I will ask only one question to have space for other questions from other people. About design of your services. Do you design these services with cooperation of your end users, or for example, you use your experience to design these services, and after that you deploy the services for your customers?
First, I have to say, I said already that our models it's backend service, so it's integrated in their legacy systems. Okay. So nothing changed in their systems, but yes, we are cooperating with them, discussing with them how it should look like, yeah, in which process they need some information, in which form. Yeah, if it will be only something like a report, or it will be something like alert, and so on and so on. So, we are using these industrial leaders or gurus, these evangelists from this procurement board platform for these discussions and co-creations. And I can say that really it's the must. Yeah, because we have different views, and we have to optimize user experience for everyone. Sometimes we are thinking about really personalized user interface and so on. So we are closely cooperating with them, and we are happy that now on these positions of directors or heads of procurement departments, they are mostly younger people and open-minded. You know, they want to digitize. They are not afraid of some new approaches. On the other hand, we have sometimes problems with understanding what's the value of AI service. Yeah, because they are buying buzzword sometimes. So also we are discussing and explaining what they have to expect from AI, how to test the value of AI service. Yeah, because these precisions and quality of AI services now are, I guess, quite crucial and tricky, because sometimes our competitors are delivering such a mess.
Oh, thank you. It was a good question.
Okay, lovely, thank you. And then, Vesna, did you have a question?
Yeah.
So
and
what?
I also have one.
Two more questions,
We have
Rado.
time until noon.
And there's something on well.
Yeah, I'll check it.
Hello, I'm Vesna Popović-Bugarin from the University of Montenegro. It was a very nice talk. So you see that you have a lot of questions. I will have by my own many of them, but I will ask you just two, if it is okay.
Yeah.
Okay.
One is regarding prediction of suppliers' behavior. It's a very challenging topic. I was working on one project related to e-marketing that's supposed to be in real time. I suppose that you are not doing that in real time, but anyway, I'm wondering what algorithms are you using? Do you use reinforcement learning Because we
sorry, the last question I was not able to hear.
which algorithms are you using?
Okay. Plenty. Really, on different decision or different tasks and different problems, we are using different models. We started with these traditional prediction models like XGBoost, random forest, then moved to causal forest, and we are talking about causal inference. And now we are, for example, trying to transfer causal inference or causal ML into, or how to utilize this causal ML in practical way. For example, we are trying to change weights of different dependencies in AI models through pre-processed causal data or analysis. Together, sometimes we are using semantic technologies to understand what's hidden in tender definitions when they are describing the requirements. Yeah, also answers or some offers in textual form. So we are using different larger language models, typically tuned then by GPT, but now, and this is more technical question for my colleagues, each day new model is on the place, and still we are able to find better and better models. So now I'm a little bit unsure how it will look like in 1 month, because in 1 or 2 months we would like to go to the market with some prototypes. So it's a difficult question because we are combining a lot of them.
And I think that you already answered to my second question is with incorporation of many kinds of different data and data formatting. Are you using in PDF? Because you said that you are using large language models, or
yeah, different formats. Also from mails, emails, from PDFs, from Microsoft Word formats, and so on. Yeah. Different types of data.
Thank you. That's all.
Yeah.
For example, if you are interested in this kind of approach, semantic, you can attend tomorrow's presentation, where we are trying to apply some large language model on scientific papers and to extract some knowledge and map to industrial needs or these standards needs. Yeah. So, for example, this is also very, very nice research problem and potential for AI service deployed on the market. Yeah.
Okay, so thank you for the answer, and I will continue with a couple of questions. I'm really Aunimo from Haaga-Helia, and then I guess we have time until noon, so we will then finish this morning session. But I have 2 questions, a bit related to what you have been talking to about the importance of pre-processing, for example. So as I heard from the answer you just gave, you have the documents are in very heterogeneous formats, but it seems that it's mostly natural language text. Or do you have also?
Hard to say mostly.
Yeah.
We have plenty of numeric data from transactional processes. Yeah, from negotiation, from auctions. Really huge or hard to say which type or which format is or is dominating, really.
Yes, I was just impressed by your data collection and the data that you have in your lab. So I was thinking, first of all, in which formats is it, and then of course what type of I guess you use natural language processing technologies also to do some pre-processing. And also, is it possible to access this data from outside? For example, if I, as a researcher, would like to do some research using that data, is there some openly available data also?
Regarding these NLP technologies, I guess the better answer you will get from my colleague tomorrow. I don't remember really. Last weeks we changed so many models and technologies, so now I'm not sure. But regarding the access to the data, really we are working with sensitive but also with open data. Open data are mainly from public procurement repositories or financial statement repositories, business registries, and so on. But from these industrial organizations, especially from their auction tenders, we are using NDA. Yes, so if someone would like to cooperate with us on this data, they have to sign the NDA. And for some purposes, we are open for research cooperation, but also for commercial cooperation, because we have strategic agreement with this software provider, but also this multi-level NDA agreement with all their clients. Yeah, so the sensitive information from private companies or private procurement, yeah, it's sensitive. So it's much more complicated to give an access to everybody, but it's possible, yeah, through this NDA.
Okay, thank you. This sounds very promising, and I think we will continue the discussion on this topic tomorrow. It seems that it has risen a lot of interest, so I look forward to the discussions then tomorrow with you. But thank you for this speech anyways today, and I let William close the event. Yeah.
Thank you so much.
Thank you.
Great. Thank you very much, Rado, and thank you to our speakers. This section of the meeting will be recorded, and I'll be able to upload later on to Ulysses, and we'll also share some pictures as well. And then we will have the second part of the meeting will take place later. I think we start at 1:30, wasn't it? We'll have two presentations from our joint research groups on applied AI in business and applied AI in education. So other than that, we'll use the same link as well. So please come back at 1:30, and then we can continue with the other presentations. If you have any questions in your mind until then, please share them when you come back. Otherwise, have a lovely lunch. And I think that's it. So I'll stop recording now, and thank you very much, Rado. Is he gone? He's gone. Okay. Yeah.
Thank you.
Thank you, everybody. Okay, that's it. Have a nice lunch. See you soon. Bye.